name is Robert, and today I will talk about generative art. Generative art refers to a form of art where instead of having an artist creating the art, we have some form of external system that is generating the art. Now this external system can be anything. Can be artificial intelligence, can be a machine, or can be a highly sophisticated algorithm used to generate this art. So in other words, you can think about this as an artist who have some kind of augmented interesting hands that have their own mind and that are creating the art without the help of the creator itself. So generative art is a very complex topic where the art itself is generating without any human intervention, or with human intervention just a little bit. So in order to do that, I will use a very interesting tool called processing, that is a flexible software and also a programming language that you can learn to code in this context of visual arts. So this is a program, a computer program, where you write a little bit of code, and that code is that autonomous system that I was talking about, which will generate the art. You can download this. Here is the page. You can click on this download link to download it. It is free and open source, and you can do a lot of things with it. Also, if you're new to this and don't know anything about this, you don't need to be worried, because there is a very good reference on all of the function and the programming language itself. So if you don't know anything, you can click on this reference link, and here you have all the functions of the programming language that we will use to create some form of generative art. Now it comes with a lot of examples. You can find a lot of examples on YouTube about how to do this, how to start doing this. But today I will just show you how to do something very amazing, relatively fast, using processing. So now let's get into the business. So here I have processing. I just want to mention that this is not a tutorial about how to do programming in processing, but I will try to explain as much as possible about the code and how to do this. So here we have a canvas that is completely blank, and here is actually like an editor where we write code, we write processing code in order to generate our art. Now here I have two basic native functions here, setup and draw. Now in the setup, you basically try to set up your environment in order to create your art, and the draw function is where you write all the code to generate the art. Now I just need to mention that this draw function, you can view it as a loop. So every frame, when the code is running, every frame the draw is activated. So in other words, if you write code here, it loops forever each frame to generate the art. Now you can do many interesting stuff. Like for example, you can just draw in one frame, so you don't want to loop this draw function and just want to generate the art and just stop it. So in this case we are using this function no loop, that is actually cancelling the looping function of the draw function. Now here in the setup function we have a size. Here is our the size of our generative art that we want to make. It is a screen, a second screen that will appear when we run the program, and this is the size in pixels, the 800 pixels wide and 800 pixel height. Now here we set up the background of our canvas that is white, and we put this function no loop that will just run once for our draw function. All the code here in the setup is run one time, and all the code here in the draw function normally runs multiple times. But because we have this no loop function, it will run just one time. Now here in the draw function we will write some code to generate our art. But before we will get into highly complicated algorithmic stuff, I assume that you know a little bit of math, and I also assume that you know a little bit of processing. But if you don't know anything about this, just follow along and I hope you will enjoy this. So let's suppose we want to make something very interesting like a rectangle, a shape or something to be generated. So we have everything set up, and let's create this. So we will use a function called rect. So we type rect, and this function accepts 4 parameters. So we need to give him some sort of location in our canvas, an x and y coordinate, and also we need to give it a dimension, the width and the height of it. So let's suppose we want to draw something at 200 pixels position, at the 200 pixel position. We write 200 and then 300 pixels down, and we need to have like 100 pixels wide and 100 pixels height. That's it. So we have a basic shape that we want to generate. Now let's generate this shape by running the program. Voila! So here we have our generated square. So this is a square because I use the same width and height, and the 200 and 300 here are represented by the coordinate of this point here. So the coordinate system of the canvas is a little bit different from the math that you have learned in school. So the 0, 0 coordinate is in top left corner. Here is 0, 0, and the axis goes positively from here to here, and positive on the y-axis from top to bottom. Now we just draw a very boring square. Now what we can do with this square? For example, we can modify its thickness of the line here. So let's do that. In order to do that, we will use another function called stroke weight, and we will give it a stroke weight of 2. So we make that line a little bit more thicker. Let's run the program. So now we see the same square, but it has a different thickness to its boundary. Now let's do something more interesting with this square. Of course we can move the square. So let's suppose we change the coordinate. Let's put 400 here, and now we have changed the position of our square. But we can do something better than this, and we can do something like, let's suppose we want this thickness of the border of the square to be completely random. So what I mean by random is that let's have our code decide what the thickness, when we run the program, what our thickness of the border should be. So we cannot predict the thickness of the board. It will be of the border. It will be completely random. So let's do that. In order to do that, we use a different function inside the parameter of the stroke weight function called random. And now we will generate a random number between 1 and 3. And let's run the program. So now every time I run the program, the thickness of the border of this square will be different. As you can see, I run again the program is different. Run again the program is totally different. Now let's suppose we want to have the position of this rectangular or square randomly. So we can do also this. So we can put random function here and we generate random number between 0 and I don't know, the canvas width that is 800. To do that, we use the width special variable here or constant that is actually this constant width is embedded in the processing programming, and it contains this width of the size of our canvas. Now let's add here random and height, and now it will be in different locations every time we run the program, and it will contain a different thickness of the border. Let's run the program. So now we have this, and now we run again. Now we run this, we have this. So as you can see, the square is in different locations and have different thickness of the board. Now let's do something much more interesting. So to do something more complicated and far more interesting, I've created an entire library that is generating highly complicated shapes in a grid pattern. So now I will show you we will comment this, and I will show you the library that I made. The library name is ZenLib1, and this library contains a ton of code that is basically generating 24 patterns, 24 complicated square patterns, and each pattern we can specify its location and width and height. On top of this, the thickness of this complicated shape, of each of the shapes that is generated by this library, has a random thickness. Also, I set up here the color of the line of the border, and here is the math that I use to generate the shape. Now the shape here is very interesting. It is just I just play with squares, so I have squares inside squares with different sizes arranged in different patterns to create a more complicated shape. And each of these shape is generated by a function that is generating just one shape. But we have 24 functions that are generating these 24 patterns that I'm talking about. Now on top of this, on top of the generation here, you see we have a lot of math. On top of these functions that are generating interesting shapes, we also have a very interesting function here, the random Zen function, that is basically generating just one random pattern by choosing from these 24 patterns. So you can imagine that we have 24 interesting shapes, interesting patterns, and every time we run this function random Zen, we will choose randomly from these 24 patterns, and we will draw it on the screen. So this is the functionality of this function random Zen. Now, besides this function, we have a fairly more complicated function here called random grid that is generating a random grid of patterns with a variable grid size. So let's suppose we want one pattern, one shape of this pattern that is completely random from the 24 patterns that we have, and we want to create a grid of the size of our screen, but with variable size, and each of the square or each of the shape will be completely different. So here is this function, random grid, that is generating this for us. Now another more complicated grid function. Here we have a special grid function that is generating patterns with a variable grid size, but with highly increased complexity. So what I've done here is I'm using this function here, random zen function, that is generating just one random pattern from the 24 patterns that we have, and I stack on top of that, I stack multiple random zen functions on top of them and modifying uh, the properties of that. And by doing this, I'm creating an even more complicated grid pattern to generate our art. Now, besides this, we also have a random grid tool function that is generating a random grid, but is generating this random grid with variable size, but we choose which of the patterns, which of the 24 patterns we want to use in our generated grid. So basically we have 24 patterns, but instead of using all the 24 patterns in a random selection, we just choose which of the patterns we want to be in our random generated way function. So this random grid tool will generate, it will works the same as random grid, but it can specify which of the patterns we want to use in our generated grid. So we can control somehow the randomness of our grid pattern. Now on top of this, we also have this print lib normal function that is hardwired here, is hard-coded. What is this showing? Is actually showing the collection of our 24 patterns that we have in this library. And on top of that, we also have a version of the same library that is using the same complicated shapes, but these shapes contain some kind of shade to it. So now let's draw this to see. So here we have this. So here I'm creating a variable z1 of type of my library type, and then I'm creating an object from the Zen library class that I made. Basically, Zen library here is a class, and I'm creating a variable of the class ZenLib1. And then I'm using this variable and using this function that is inside the class ZenLib1, print lib normal, to show me all of the patterns that we have in this library. So if we run this program now, here we have all of the patterns that we can create or we can generate by this library, arranged in a grid, and all of these are basically the functions of the library. So in other words, all of the patterns that you saw in the library Zen, all of those shapes are here arranged in a grid so we can see how they look. So this is not an art, this is just generating all of the possible patterns that we can use in generating our art. Now we can also see the shade version of the library. So here the shade version of the library, I'm just using some of the previous patterns in the library and just modify them with this interesting shade. So these are just the variation of the same shapes, complicated shapes that I'm using in the Zen library. Now, to make something more interesting, and now we are going into the actual generative part of it. Let's use our random Zen function. So this random Zen function is creating just one pattern from the 24 patterns that we have, and puts it and draw it on the screen. So let's run this program now. So now we can see that we have just one possible pattern from the total possible patterns that we have in our Zen library generated on the screen. So if we run the program multiple times, we will see the different patterns emerges. As you can see, different patterns. Interesting. Now, by using this idea, we will create our generative art. So now let's use our random grid function. So this random grid will pick it will create 5 shapes on the width of the screen and 5 shapes on the height of the screen, and each of the shape from the total 24 patterns that we have, it will be completely random. So now let's run this program. So now you can see that we are using the library, the shapes from the library arranged in a grid, but each of the shape is completely random, picked from that 24 patterns that we have. So we have 1, 2, 3, 4, 5 patterns on the width and 1, 2, 3, 4, 5 on the height. So as you already see, we are starting to generate some very interesting art, some very interesting pattern art, abstract pattern art. So now we can do even better than this, and now we can use random grid tool. So random grid tool, we can pick from that 24 patterns. We will generate the same grid 5 by 5, but we will use the whole range of our patterns that we have in the library. So now we run this program, we see the effect is the same. So if I run the program again, it will generate a different pattern. So this is like an art, it's generating different patterns. But let's suppose we want just we want something interesting, like let's put this again. So let's suppose that we want to create that grid of randomness, but we want to use only this row of shapes. So we want to use this shape, this shape, this shape, and this shape only, and we don't want to use these shapes here. So we can do that by using random grid tool and specifying here that we just want to use those patterns. So if we run the program, sorry, need to stop this. Okay, now if we run the program, we have again the five patterns, shapes in our width and 5 on the height, but as you can see, the pattern has changed because we are using just 4 patterns from our library to generate art, but each pattern is totally random. So if I run the program again, it's completely random every time, but we are not using the whole range. Now let's suppose we want to use a different set of patterns. Let's run this to see what patterns we have. So let's suppose we want to have only this row here, as you see with my mouse cursor, only this row. So row number 3, we want to use this shape, this shape, this shape, and this shape only in our grid. Okay, in order to do that, we need to specify like this. And now if we draw the program, again run the program, now you can see that we have the grid in random order but we are using only those patterns. Okay, okay. Now this is pretty boring, so let's go to the more interesting, crazy stuff. So now we are getting into serious generative idea, where we are using the random grid A. So now the random grid A is stacking multiple random Zen functions on top of each other and using the whole range of patterns that we have. And this will create a far more complicated pattern because we are having a stack of multiple random Zen grids. So basically we generate one grid using the random Zen function, and then we stack upon that at different location another random Zen grid uh, layer, and then we are stacking actually multiple layers of random Zen grids on top of each other, and this totally random creates a very interesting pattern. So let's see this. So as we run here we just have five shapes on the width and 5 on the height, but because we are stacking multiple grids on top of each other, we are creating a far more richer, far more complicated pattern that is completely random. So this looks quite interesting. Now if you run again, you will see that it's completely random. Let's run again. Completely random. Very interesting. But now we can do something more crazy. So let's suppose we combine all of these functions from our Zen library into a more interesting manner. So we have this, that is our final art. So this is basically our final generative art. So here I'm generating a random grid A, 10 by 10, and then on top of that, remember that this random grid A is already a stack of random Zen grids. We generate this, and on top of that we generate again the normal random grid, and then again we generate a different size of random grid A, and then again the random grid, the normal one, and then again the random grid A, and then again the random grid A, but with different sizes. So what it will happen if we do this crazy idea of stacking so many different layers of grids? And voila, magic happens. So my friends, this is the idea behind this generative art. So we are using computer code and algorithms, math, in order to generate very interesting patterns. So here, as you can see, voila, we have a very interesting, highly complicated pattern that is completely random. So if we run here this, instead of just trying to do this by hand, imagine that every time we run the program, the code decides how to draw this and creates our art completely different. So it doesn't matter how many times we run the program, every time we run the program, the art it looks almost the same, but it's completely random. So it has variation, so it has basically infinite variation. So every time we run this, we will have different patterns, and here is our art. So every time we run this, it generates very interesting patterns. Now we can do something more interesting by adding a little bit of color to this. So we modify here the color system of our library by adding this marvelous thing. Here is just a variable that holds the color. So here we have white and black, but white and black here is actually white. The white is white, and the black here is just a very dark red combined with a random number value for the blue parameter here. So the colors here in processing are RGB models. So we have red, green, and blue combined together to generate very complicated colors. So if we change this and run again, you will see that the effect is absolutely amazing. So here we have, on top of the randomness of the patterns, we have random color added to our art. So every time we run this, we have different colors and different patterns. So I hope you like this. This is just 0.1% of what you can do with processing. I'm not an expert in processing myself. I just started learning it, and it's just crazy fun, and it opens your mind. And by combining and changing and even adding more features to this library, you can eventually create some very sophisticated art. So this this art is not created in an artistic way, that I'm an artist and I'm just hand drawing it, or I don't know, just trying to draw this manually. I'm using computer code in this case. Our autonomous system is the computer code that when we run it, the computer decides how the art should be generated. So make or generated or created, whatever you want. So here we have a very interesting art that basically is generated by our machine, by our computer. Of course, we need to use a ton of math in order to create the algorithms that are used by the machine, but that's the fun of it. So um, the beauty is that you use mathematical functions, and the mathematical functions can give you some very interesting art that if you try to choose to make it manually, it's just a pain, because it will take a lifetime to make this as a hand drawing. So that's it. This is what I wanted to show you, and you can follow the link in the description where you can download this marvelous processing tool, and you can start mess up and do your own shit, and create some very interesting stuff, you know. Like we never try to use any fancy things here, so we just use a couple of squares, a grid, then we try to randomize the border of this grid, border of every shape of this grid, and then by stacking this very powerful idea of stacking multiple grids on top of each other and just shifting them as location, we create this interesting art. Um, Now I just want to show a little bit. So yes, in order to create these shapes, I um, I use this idea of having just a square, and then I put multiple squares arranged in a very interesting pattern using math inside that square, and then the whole bunch of collections of square are put together into just one pattern, and then I created multiple patterns, and then I use this idea of generating random grids of patterns and then stack upon each upon other, and that's the whole point of it. That's the whole algorithm. That's the whole idea of it. But as you can see, the result is this very interesting, crazy pattern that looks completely chaotic and completely complicated and very interesting. So thank you very much, and I hope you like this. Uh, and I don't know if you really like this a lot. Please let me know, and I will make more videos about this marvelous thing called processing. So in the meantime, take care and each others. Take care and each others. Bye bye.